All right, so this is going to be week 7 homework help. So I'm going to start with questions from homework 1. Question number 2 says f prime of x at the given value. So I have a function f of x and I need to find the derivative and find it evaluated at 3, which basically means what's the slope of the tangent line at 3. All right, so right now we have to use the limit definition of a derivative. So f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x over h. All right, so if I plug in x plus h for my function, I get negative 8x plus h squared plus 6 times x plus h plus 8 minus my function f of x, negative 8x squared plus 6x plus 8, all over h. Now we can't take this limit because if I plugged in 0 for h, I would get something that's undefined. So we're going to have to simplify the numerator. So the first thing I'm going to do is I'm going to distribute the negative 8 and the 6. And then notice, first of all, the x plus h squared is x squared plus 2xh plus 8 squared. What you looking at, bud? Plus 6x plus 6h plus 8. And then distribute that negative sign so that I get a plus 8x squared minus 6x minus 8 all over h. So then I'm going to distribute that negative 8. So I have a negative 8x squared minus 16xh minus 8h squared plus 6x plus 6h plus 8 plus 8x squared minus 6x minus 8. I think I lost my plus 8. No, there it is. All over h. All right, so now we're just going to get rid of things that are alike, add like terms. So I have a negative 8x squared, a positive 8x squared, a 6x, a negative 6x, an 8, a negative 8. What I have left over in the numerator is a negative 16xh minus 8h squared plus 6h all over h. I'm going to factor out an h from the numerator, and that gives me a negative 16x minus 8h plus 6. Right, my h's cancel, and then I can plug in my 0. So I have a negative 16x minus 0 plus 6. So my derivative, let me write it up here, is negative 16x plus 6. All right, and they want us to find f prime of 3. So now we just need to plug in 3 to our derivative. This real quick. All right, so f prime of 3 is equal to negative 16 times 3 plus 6. I'm getting a negative 42. So my answer is A. All right, next question. Find the equation of tangent line to the curve when x has the given value. All right, so the first thing I need to do is I need to find the derivative. All right, the slope of the tangent line is the derivative, right? So if I take the derivative and plug in 8, that will give me the slope of the tangent line at 8. Okay, so again, f prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. So I'm going to plug in x plus h and I get a 16 over x plus h minus my function, which is 16 over x, and all of that is over h. Again, we're going to have to do some algebra because we can't directly plug in h because that would give me something that's undefined. What I'm going to do is I'm going to multiply the numerator and the denominator by the common denominator in the numerator. All right, and that is x times x plus h. So when I multiply that first term, my 16 over x plus h, the x plus h is going to cancel. So I'm going to end up with a 16x. When I multiply that second term, my x is going to cancel, and I'm going to get a 16 times x plus h. All right, and everything's going to stay in the denominator. I'm going to go ahead and distribute my 16, my negative 16. So I get a 16x minus 16x minus 16h all over x times h, x plus h. All right, so my 16x cancels. I am left with a negative 16h over x times h, x plus h in the denominator. My h's cancel, and now I can plug in my 0, hey bud, and I get a negative 16 over x times x plus 0, which gives me a negative 16 over x squared. All right, so if I want to find the slope of the tangent line at 8, I need to plug in 8 to my derivative. So I have a negative 16 over 8 squared. What does that give me? If I cancel 1, 8, I get a negative 2 over 8, which is a negative 1/4. All right, so we have a slope. That is my slope. And now I need a point. They give me that the x value is 8. So to find the y value, I need to plug it into f of x. So f of 8 is 16 over 8, which equals 2. So my point is 8, 2. All right, so now what I'm going to do is I'm going to plug it into y equals mx plus b. My y is 2. My slope is negative 1/4. My x is 8. All right, so 8 times a negative 1/4 is negative 2. Add to both sides, and I'm going to get 4. So the equation of my line equals y equals negative 1/4 x plus my y-intercept is 4. All right, next question. If f of x equals x squared minus 3 over x plus 9, where is f not differentiable? All right, so a function is differentiable everywhere in its domain. So the one number that is not in the domain is x equals negative 9. So f is not differentiable at negative 9. All right, the next question. For f of x equals 8 over x, find an equation of the secant line through the points where x equals 5 and x equals 8. So the equation of the secant line, well, let's start with the slope. So that is f of 8 minus f of 5 over 8 minus 5. All right, so if I plug in 8, I get an 8 over 8 minus 5 over 8 all over 3. 8 eighths minus 5 eighths is a 3 eighths. Let's multiply by the reciprocal, which is 1 over 3. And that gives me my slope. My slope is 1/8. All right, I can use either point. I'm going to use 8 because when I plug in 8, I'm going to get 1. All right, so I have a slope of 1/8 and I have a point of 8,1. So again, we're going to plug into y equals mx plus b. My y is 1. My m is 8. No, my m is 1/8. My x is 8. And I need to find b. So I end up with a 0 for b. And that gives me the equation y equals 1/8 x. Now, the equation of the tangent line at x equals 5, I have to find the derivative because that gives me the slope of the tangent line. So f prime of x equals the limit as x goes to, as h goes to 0 of f of x plus h minus f of x all over h. So f of x plus h is 8 over x plus h. Then minus f of x, which is just 8 over x all over h. Again, I am going to multiply by the common denominator in the numerator, which is x times x plus h. So when I do that, the first term, what's going to cancel is the x plus h. So I have an 8x left. In the next term, what's going to cancel is the x. So I'm going to be left with 8 times x plus h all over x times h times x plus h. All right, so let's distribute our negative 8. I have an 8x minus 8x minus 8h. All right, so my 8x cancels, and I'm left with a negative 8h on the top. So my h is going to cancel. So now when I plug in my 0, I get f prime of x is equal to negative 8 over x times x plus 0, which is negative 8 over x squared. All right, so we have, we need to plug in 5 so that we can find the slope at that point. So negative 8 over 25. And now I also need to find the point, right? So the point is when y equals f of 5. So the y value is f of 5. Y equals f of 5, which is 8 over 5. All right, so now I have a point and a slope. So my point is 5/8, and my slope is equal to negative 8 over 25. All right, so let's plug into y equals mx plus b so we can find our y-intercept. Y is 8/5. And m is negative 8 over 25. And x is 5 plus b. So these 5s are going to cancel. I'm going to get a 16 over 5 is my y-intercept. So the equation of my line is y equals negative 8 over 25x plus 16 over 5. All right, next question is, again, find the equation of the secant line, find the equation of the tangent line. All right, for the secant line, we know that the slope is going to be f of 9 minus f of 4 over 9 minus 4. If I plug in 9, I get a 7 times 3, which is 21. If I plug in 4, I get a 7 times 2, which is 14. All over 9 minus 4, which is 5. All right, so the difference between 21 and 14 is 7. So my slope is 7/5. We just need 1 point. I know that f of 4 is equal to 7 times 2, which is 14. So I have the point 4, 14, and I have the slope 7/5. So I'm going to plug into y equals mx plus b so that I can find the equation of my line. My y value is 14. My slope is 7/5. My x is 4 plus b. All right, so I have a 14 minus 28/5 equals b. And I get a 42/5. So the equation of my secant line is y equals 7/5 x plus 42/5. All right, now we want to find the equation of the tangent line. When x has the first value, so at x equals 4. All right, so first thing I need to do, again, is find the derivative. So the limit as h goes to 0 of f of x plus h minus f of x all over h. And f of x plus h is going to be 7 square roots of x plus h minus f of x, which is just the square root, 7 square roots of x, all over h. I'm going to multiply by the conjugate of the numerator since I can't directly plug in 0. So that is 7 square roots of x plus... Whoa.
I found this on the web.
Oh, thank you. There we go. All right, 7 square roots of x plus h minus or plus 7 square roots of x, both the top and the bottom. In the top, we will distribute. In the bottom, we will not. Distribute, meaning FOIL. So if I multiply the first terms together, I'm going to get a 7 times x plus h. The middle terms are going to drop out, right? That's the whole point of the conjugate. And then the last term is going to be, whoops, I have a 7 times 7, so that's a 49. So a 49x plus h minus a 49x all over h times the 7 square roots of x plus h plus 7 square roots of x. All right, when I distribute that 49, I get a 49x plus a 49h, but I am subtracting off a 49x. So I'm left with a 49h in the numerator. And in the denominator, I have an h times 7 square roots of x plus h plus 7 square roots of x. H's cancel, and now when I plug in my 0, I get a 49 over 7x plus 0 plus 7 square roots of x. All right, this gives me a 14 square roots of x. Let's cancel one of our 7s, and I get a 7 over 2 square roots of x. All right, so my derivative is 7 over 2 square roots of x. All right, we want to know the equation of the tangent line at x equals 4. So the slope is going to be f prime of 4. So I have 7 over 2 square roots of 4. Square roots of 4 is 2, so I end up with 7 over 4. That's my slope. My point at 5, the y value is going to be, man, I keep asking Siri. Go away, Siri.
I'm not sure I understand.
That's fine. Okay. So I have 7 square roots of 4, which is 14. So I have the point for 14. And my slope is 7/4. Again, we plug into y equals mx plus b. My y value is 14. My m value is 7 over 4. My x value is 4. So b is equal to 7. So the equation of my tangent line is y equals 7/4 x plus 7. All right, so now this is on homework 2, and now we can use the power rule to find derivatives. So this one is just asking me to find the derivative. All right, and the way that we find derivatives is we bring down the exponent, so 9 times 0.7, and then we subtract 1 from the exponent. We're going to do the same thing for the next term. So I have a negative 4 times 1.2 u to the 1.2 minus 1. All right, so I have a 9 times 0.7, which is 6.3, u to the negative 0.3, 4 times 1.2, 4.8 u to the 0.2. That is f prime of u. Power rule. The next one is also find dy dx, which means just find the derivative. The first thing I'm going to do is I'm going to rewrite it in a way that I know how to take the derivative. So remember, the square root of x is the same thing as x to the 1/2. I'm going to bring that up into the numerator, so that makes it a negative 1/2. So to take the derivative, I'm going to bring down the exponent and multiply that by a negative 11, and then subtract 1. So I get 11/2 x to the negative 3/2. You can write it as 11/2 or 11 over 2x to the 3/2 if you want. Either is acceptable. All right, the next question says, find the point on the graph of the given function at which the slope of the tangent line is 6. All right, so they give me a function and I want to find every place in that function where the tangent line has a slope of 6. So it means I'm going to take the derivative and set it equal to 6. So first off, the derivative, bring down the 3, x, subtract 1 from 3, which gives me 2. 9 times 2, 18. Subtract 1 from the exponent 2, which just gives me 1. Plus 33. All right. Now we want that to equal 6. So we want to find all the x values where the slope equals 6. All right, so 33 minus 6 is 27. So the 3x squared plus 18x plus 27 equals 0. Let's factor out a 3 so that I get x squared plus 6x plus 9 And that gives me an x plus 3 times x plus 3. So the x value is equal to -3. They want us to type an ordered pair. So that means I also need to find the y value. So f of -3 is equal to -3 cubed plus 9 times -3 squared plus 33 times 3 plus 14. All right, so I have a -3 cubed plus 81 plus 99 plus 14. I'm getting 167. So at the point, -3, 167. Let me check my number one more time, so I don't trust myself. -3 cubed plus 9 times 3 squared plus 33 times 3 plus 14. All right, getting the same thing. All right. So that's the point where the tangent line has a slope of 6. All right, next question. Assume that a demand equation is given by Q equals 5,000 minus 100p. Find the marginal revenue for the given production levels, the values of Q. So normally we see this demand function solved in terms of price, right? So I'm going to go ahead and do that. So 100p. Whoa. So the reason why I need to do this, let me just say, we need to find the revenue function, right? And the revenue function is the price per unit times the number of units. In our case, it's the production level. All right. So I need to figure out my price function. So I'm going to solve for P. So I have 5,000 minus Q. Divide by 100, and I get 550 minus Q over 100. All right, now my revenue function is going to be Q times P, which in our case is Q times 50 minus Q over 100. So 50Q minus Q squared over 100. So I need to take the derivative. So when I'm thinking about marginal revenue, remember the marginal revenue is approximated by the derivative. So R prime of Q is 50 minus 2Q over 100. So R prime of Q is equal to 50 minus Q over 50. First, they asked us to find the marginal revenue when there are 1,000 units. So R prime of 1,000 equals 50 minus Q, 1,000 over 50. All right, so that's going to give me 50 minus 20, which is equal to 30. So that is the marginal revenue at 1,000 units. They want us to do the same thing for 2,500, and I'm going to let you do the last one yourself. So 50 minus 2,500 over 50. So I believe I'm going to get 50 minus 50, which is 0. All right, next question. It says if the price in dollars of stereo system is given by P of Q equal to 2,000 over Q squared plus 500, where Q represents the demand for the product. Find the marginal revenue when the demand is 10. Okay, so again, when we think about the revenue function, we want to know the price times the number of units, in our case, the demand of units. So R of Q equals P times Q. All right, so that's A. And if I compute that, I get 2,000 over Q squared plus 500 times Q. Let's distribute that Q. So I get a 2,000 over Q plus 500 Q. Now, since we're looking for the marginal revenue, we're going to have to take the derivative. So I'm going to rewrite this as 2,000 Q to the negative 1 plus 500 Q. So the derivative of my revenue function is I'm going to bring down the negative 1, which gives me negative 2,000. And I subtract 1 from the negative 1, and I get a negative 2. And the derivative of 500Q is just 500. They want us to know the marginal revenue when the demand is 10. So we're going to plug in 10 to our derivative. So I have a negative 2,000 over 10 squared plus 500. So that is going to give me 500 minus 20. So we're going to get 480. So that's my marginal revenue at the demand of 10. All right. Number 14 says find all values of X where the tangent line is horizontal. All right. So that when the tangent line is horizontal lines have slope 0. Right. So what I need to do is I need to take the derivative and set it equal to 0. So f prime of X, bring down the 3, multiply by 2, and that gives me 6. Subtract 1 from 3, and that gives me 2. Bring down the 2, and I get 39 times 2, 78. The derivative of 216x is 216, and the derivative of 5 is just 0. All right. So we're going to set this equal to 0. Let's see if 78 is divisible by 6. It is. So I'm going to factor out a 6. So I have an x squared plus 13x plus 36. So I need two numbers to multiply to be 36 and add to be 13. So let's see. 36 is 2 times 18, 2 times 9, 3 times 3. So what, 9 and 4? 9 and 4. So x plus 9, x plus 4. So x equals negative 9 and x equals negative 4. All right, so my horizontal tangent lines are going to be at negative 9 and negative 4. That also means where the graph is going to turn around. All right, next question. The graphing calculator window shows the graph of a function f of x and its derivative. Decide which is the graph of the function and which is the graph of the derivative. All right, so first of all, I kind of want to look at where it has horizontal tangent lines. So let's look at y1 where it has horizontal tangent lines. It has a horizontal tangent line here, and I think that's it. All right. So now what I know about the derivative is the derivative when the tangent line is 0, it's going to cross through the x-axis. Well, y2 crosses through the x-axis right here. The other thing I know, when the function is decreasing, the derivative is going to be below the x-axis. So right here. When the function is increasing, which I have, maybe let's make it a different color. Increasing, so this function is increasing, then the derivative needs to be above the x-axis, which this is above the x-axis. All right, so it looks like my function is y1 and the derivative is y2. All right, and I believe this is my last question. It says sketch the graph of the derivative. All right, so let's take a look at this. I know that this line right here has a constant slope. So the derivative is going to be constant. That constant slope is 1, so that derivative should look like just 1. All right, all the way up to -3. All right, now there is a horizontal tangent line at 0, so it needs to cross the x-axis there. And it's increasing between, is that -2 to 2? So it should be above the x-axis the whole time. All right, I don't know really what it looks like, but it should be above the x-axis. So I'm going to leave this for right now and just say it's above the x-axis. All right, now this slope right here is a -1. So it should look like it's constant as well, right? Because that's a line, so it has a constant slope. It's decreasing, so it should be below the x-axis. All right, so let's take a look at these. Let's see, I should make these endpoints more clear. Oh man. All right, because these should all be open circles because they're not differentiable there because they do not have limits there, right? The limit from the left and from the right are different. All right, so I can get rid of this one because that middle part is below the x-axis. I can get rid of that one because part of it's below the x-axis. And then these two lines are switched on that one, so here's my graph. All right, and that's the last one. All right, I hope you guys had a good weekend, and I will see you soon.